In this video, we'll look at Java Cyclic Barrier. Cyclic Barrier is a synchronization aid that allows a set of threads to wait for each other to reach a common barrier point. The threads who reach the barrier point has to wait for other threads to reach. As soon as the threads have reached the barrier point, all of them are released to continue. A cyclic barrier is usable, so it's more like a racing tour where everyone meets at a waypoint before proceeding on to the next leg of the tour. Cyclic barrier can be reused after the waiting threads are released, and that is where it is different than countdown latch. We can use cyclic barrier by calling reset method, which resets the barrier to its initial state. Example of cyclic barrier: a multi-threaded download manager. The download manager will start multiple threads to download each part of the file simultaneously. Suppose that you want the integrity check for the downloaded pieces to be done after a particular time interval. Here cyclic barrier plays an important role. After each time interval, each thread will wait at the barrier so that the thread associated with cyclic barrier can do the integrity check. This integrity check can be done multiple times thanks to cyclic barrier. Cyclic barrier example: we'll be implementing the sum of 15,000 numbers with cyclic barrier in 3 steps. In the first step, we will sum numbers from 0 to 5,000 using 2 threads. In the second step, we will sum numbers from 5,001 to 10,000 using 2 threads. In the third step, we will sum numbers from 10,001 to 15,000 using 2 threads. At the end of each step, all the threads will wait for each other to complete and then proceed to the next step using cyclic barrier awaits method. We will print the total sum after the 3 steps. We will use executor service and will call the callable using submit to get the results in future object and sum the future object once the await returns. Now let's implement this example in IntelliJ. So let's first create a new class, and the class name is sum of number using cyclic barrier. So first, we'll be creating 3 array lists, and each array list will contain 5,000 numbers. First array list will contain number from 0 to 5,000. Second array list will contain 5,001 till 10,000, and third one will contain 10,001 till 15,000. Integer. So let's create our first array of numbers is equal to int string dot range close 0 to 5,000 dot to array, and private static int array2 is equal to int string $10,000 dot to array. And third array is from 10,001 till 15,000. And now for verification purpose, we will create an integer variable total, and we'll be using the int stream sum method to calculate the sum of 15,000 number. And now we will create an instance of cyclic barrier. And we'll be using 3 cyclic barriers because we'll be collecting because we'll be using in 3 steps. First step is sum of 5,000, then the second one is 5,000 to 10,000, and third one is 10,000 to 15,000. Now let's create public static void main, and inside public static void main we'll be creating 2 callables. Callable 1 and integer sum is equal to 0 and sum is equal to sum plus calculate sum 0. So we are separating out so that we don't have to do all this implementation inside, because we'll be doing the 3 implementations, so just separating it out into a method. So array of 1 dot length divided by 2 and array of 1. So let's implement our calculate sum. So it has created the calculate sum method for us. Inside the calculate sum will be, let's call this start and this is end, and integer sum 1 is equal to 0, and for integer I is equal to start, integer I is less than end, and I plus plus. Sum 1 is equal to sum 1 plus array of I. Let's call this array. Return sum 1. So that's all for our implementation of calculate sum method. Now let's come back over here, and now after this we want both the 2 threads to wait for completion. So we'll be calling cyclic barrier dot await. Now sum is equal to sum plus calculate sum, and here star is equal to array 2 dot length, or here star is equal to 0 and array 2 dot length divided by 2, and array of 2. Again, we want all those or both the threads to have a touch point before continuing on with the next step. And sum is equal to sum plus calculate sum start, again the 0, and array 3 dot length divided by 2 and array of 3. And then return sum. Now callable 2 is equal to, and integer sum is equal to 0 and sum is equal to sum plus calculate sum, and here the start is array 1 dot length divided by 2 till array dot length and array of 1. Sum is equal to sum plus calculate sum. Here the start is array of 2 dot length divided by 2 and array of 2 dot length and array 2. Sum is equal to sum plus calculate sum. Start is array of 3 dot length divided by 2, array of 3 dot length, and array of 3. And in between we are waiting for cyclic barrier dot await, and here we need to do cyclic barrier dot await too. Await and cyclic barrier dot await, and here cyclic barrier dot await, and return sum. Now let's create an executor service. Executor service is equal to executors dot new fixed thread pool of 2, because we have 2 threads, so that's why we're creating a thread pool of 2. Now we'll be calling those 2 threads using submit. So future of integer sum1 is equal to executor service dot submit, and callable 1, and future integer sum2 is equal to executor service dot submit with callable 2. Now let's print out calculating our first sum. So sout and calculating first sum, and cyclic barrier dot await. So let's add exception handling. Then print out calculating second sum and cyclic barrier dot await. And here let's print out first sum is created, first sum is calculated, first sum is calculated, and here second sum is calculated, and print out calculating third sum and cyclic barrier dot await, and third sum is calculated. Now we will get sum integer sum is equal to sum1 dot get plus sum2 dot get. Okay. And print out the sum of 3 arrays is plus sum and correct sum is plus total. Let's make this static. And executor service dot shutdown. So let's go through the program one more time. So what we have done is that we have created 3 arrays with 5,000 numbers each, and then calculate total using the endStream.sum method, and then initiate cyclic barrier with 3 count. And then afterwards created 2 threads, callable threads. In the first thread I am calculating sum from 0 to half of the array length and calling cyclic barrier to await. So after this, every sum I'm calling cyclic barrier.await, and here I am printing out at this point is cyclic barrier.await. So all 3 of them will combine at this point. So it won't continue until all of them check at the same time. So here first check is done and it will print out first sum is calculated. Now at this point the second check will be done by all the threads and it will print out second sum is calculated. At this point third check will be done and will print out third sum is calculated, and then afterwards we are getting the sum into the main sum from the 2 threads and printing out some of the 3 arrays, some of the number from 3 arrays is this and correct sum is this. So let's run this program. So you can see that calculating first sum is calculated. All the three threads did a checkpoint at this time, and it printed out first sum is calculated. Then it prints out calculating second sum, and then after all the threads did the check, second sum is calculated, third calculating third sum, and all of them meet at the before third sum is calculated, and once they check at that point, then third sum is calculated, and you can see sum of 3 arrays 11207500, and the correct sum is the same.